Sorry, I had to stop for a sec there. My videos have to be under 15 minutes, so I kind of hope that one uploads on YouTube. So then, this is where your thing is going to be located tomorrow. It's going to start to shift to the north and east. Your low is actually going to start to close off as it heads north to the east. So, big snowstorm on the northern side. We're now into the day on Friday, and then it shifts out of here for the weekend and affects the northeast. Okay, so that's what's going to be going on for the setup. Okay, for the disturbance that's going to be coming in. Now, I'm going to throw a lot of things at you now. And I hope you don't get intimidated by all these things that I am throwing at you. Please don't be alarmed. I will try my best to do this as structurally and logically as possible. But you need specific things for thunderstorms to develop. You need instability, which is the rising of air off the ground. You need strong winds in the low levels, which would be your low-level jet. You need wind shear, and you need moisture. Okay, so we're going to take a look at each of these 4 key things on weatherbell.com using the European model. Okay, so this is our analysis of instability. This is what we call CAPE, surface-based CAPE. And so what CAPE does, it is a measure of the rising action off the ground. The more the ground heats up, the more CAPE and instability, the higher your CAPE values are, which means the more instability you have. And the more instability you have, the quicker thunderstorms are going to form upwards into the atmosphere. They're going to form vertically. And that's why when you have high values of CAPE here, anywhere in the yellow and green and orange and red areas here, you're going to have a threat for some potentially damaging large hail. Because as the storms form vertically into the atmosphere, those cloud tops get higher into the colder regions of the upper atmosphere there, and water droplets can freeze. And because you have a strong updraft that's the powerhouse of your thunderstorm. An updraft is when warm air is advecting upward into the thunderstorm. That's why they form vertically upwards. Your updraft is going to, as the hail tries to fall, it's going to pull the hail back up, and it'll accumulate more ice pellets, come back down again, go back up, come back down again, until it becomes heavy enough where the updraft of the storm can't hold it anymore, and it falls down as large hail. So, the more CAPE you have, again, anybody in the green, orange, red, the bigger your threat for large hail is going to be. So this is at 7 p.m. tomorrow evening. This is probably going to be the prime time for severe weather tomorrow. So if I had to pinpoint an area where I think you're going to see extremely large hail, eastern Texas, western portions of Arkansas, Louisiana, southeastern Oklahoma, southeastern Missouri, southern Illinois, western, I think that's Indiana there, and western Kentucky, western Tennessee, and maybe even northwestern Mississippi. This is your primary area for severe weather tomorrow, actually. And if you look here across Texas, you can see, and Oklahoma, and these areas in yellow, these are CAPE values in excess of 2,000 to 3,000, and even more across eastern Texas, southeastern Oklahoma, joules per kilogram. So this is going to be conducive to very high-top thunderstorms that will be surface-based. So again, we'll be looking at supercells forming off the surface of the ground here, and you're going to get a very big, large hail threat. So that's one thing. Your next ingredient here, you need moisture. So what you look for is you look for high dew points. See, I'm losing my voice now. Excuse me. So anywhere in the yellow and the brown, these are going to be dew points. of 60 or more. Especially back in here, your darker browns are dew points of 65 up to 70. And what that means is you have a lot of moisture coming in from the Gulf because of, where is it? Low-level jet. You see this? So let's go back to dew points in a minute. But first, you have your center of low pressure, which is up in here. And on the southeastern side of that trough that's going to be coming in, your winds in the low atmosphere, the low levels of the atmosphere, are going to be pretty strong. You can see the arrows are pointing up from the Gulf here. And the green and the yellow there, that's going to be winds in excess of 40 to possibly 55, 60 knots in the lower levels of the atmosphere. So you have a really strong low-level jet. And what that does, excuse me, my voice is going to sound like this for the rest of the video, so I hope you guys don't mind. But what that does is that advects moisture from the Gulf out ahead of your cold front here. And also, that's the number one thing it does. And you need moisture to increase instability and to provide, moisture for storms to produce heavy rain. Number two, it advects warm air from the Gulf here. And that warm air coming in is what fuels the updrafts of the thunderstorms for them to form as well. So the warm air comes advecting, it rises vertically, as I said before, with CAPE. So the low-level jet aids in the transfer of that warm air into the updraft of the storm, and that helps keep them going. So again, you'd be looking for supercells to develop with that. And the last thing the low-level jet does is it adds to wind shear and the chance of storms rotating and forming tornadoes. So anywhere in this green and yellow area, you have a threat of tornadoes. Going back to dew point, the low-level jet aids in that transfer of moisture coming in. So anywhere east of the blue here, this is your cold front actually, and then your cold front extends back across like that. Well, actually, hold on a second. I want to look at temperatures first. Your cold front, your area of low pressure is up here. This is temperature map now. Your cold front extends back across northwestern Missouri, Kansas, Oklahoma here, and then back into New Mexico. So this is your cold front. You have one area of low pressure up here, one down here. So the cold front is going to be your initiating factor for storms to form in this area further north and east. And then to the south, here, you have what we call a dry line from the second area of low pressure down here. So you can see these temperatures are also very warm. You need warmth for these thunderstorms to develop. And these are really warm. You have temperatures going up into the 80s across Texas. 70s, 60s, all down in here. 60s and 70s and some lower 80s as well. So that's really good. Now coming back to dew point here. See the difference here? This is temperature, dew point. This is moisture, temperature. So moisture, warmth, moisture, warmth. So your cold front is back in here. Your dry line is down here across central Texas. See this push of dry air behind it? That's dry desert air, and this is warm, moist Gulf air coming out ahead of your dry line. So you have moisture out of your cold front, moisture ahead of the dry line here. You got two initiating factors for severe storms to develop tomorrow. Alright, so we've talked about that. We talked about the low-level jet. We talked about temperatures. Vorticity we already looked at on the American model. This is just a map of where we're going to be at tomorrow evening. Your first center of low pressure is going to be up here across Missouri and southern, what state is that? Iowa, I think. I could be wrong. Your second area of low pressure back down across Oklahoma and Texas. So cold front, dry line, cold front. And you see precipitation on the eastern side. Alright, I think we've looked at all of this now. Alright, now the last thing here. Now, this is a model of CAPE from the NAM. We're going to look at something called Helicity. Now, So we talked about CAPE, we talked about the low-level jet, we talked about dew points. The last thing that you need for severe thunderstorms producing tornadoes to develop, you need strong directional shear, meaning at different levels of the atmosphere. In the lower atmosphere, the winds are going in a certain direction. In the middle atmosphere, the winds are going in a different direction. In the upper levels of the atmosphere, they're going in another different direction. Since the winds are going in all different directions, we call that directional shear. And what that does is it helps the updraft of your supercell thunderstorms to rotate. And if your updrafts are close to the ground, which is going to be suitable since there's a lot of surface-based CAPE and moisture, your updrafts will be rotating close to the ground. That's going to aid in tornado development. You have your low-level jet, and you have strong vertical shear, which means as you get